In this tutorial, we're going to talk about two key structural components that are a basis of the Python language and how understanding their design can make or break your coding success. Hey, it's Chris with A to C Python Academy with more tips and tutorials to help you be the budding Python developer we both know you can be. Thanks for being here, and if you haven't already, tap that subscribe button and don't forget to hit the notification bell icon so you don't miss a new tutorial. So in our previous video, we spoke about multi-line statements. We covered the three categories of multi-line statements and the character combinations that are represented in each category. In addition, we spoke in detail about the 4 points of multi-line statements and their basic rules of operation. If you have not seen that video or would like to revisit that video, I have posted links in the description below, or for your convenience, you can click on the link in the top right of the screen for that video. Also, if you want to watch a specific section of this video, I have included timecodes in the description below. That way, you can watch exactly what you need to know. In today's class, we're going to talk about code blocks and indentation levels in Python. We'll discuss how they're set up, the simple ways to identify them, and the rules related to their proper function. We'll also dive into the well-known error messages that you may come across while working with Python code blocks, whether it's syntax, indentation, logic, or tab errors. And finally, we will conclude with coding examples to bring your understanding all together. Let's get started. So what is a code block? Sometimes referred to as a block of code or suite, it is technically defined as a group of statements that can be and is executed as one unit. Examples in Python include things such as modules, class definitions, or a function body. In more relatable terms, if you ever had to write a research paper in high school or college and needed to cite your sources using MLA or APA style, it is the same concept. The first line of the block of code is usually left aligned depending on the location and the use of the Python code in the program, and every line of the code after the first line inside that block of code is indented 4 spaces. Now let's talk about indentation. The PEP8 guide rules for indentation states, use 4 spaces per indentation level. Spaces are the preferred indentation method. Tabs should be used solely to remain consistent with code that is already indented with tabs. Python disallows mixing tabs and spaces for indentation. As you're now aware, indentation plays a huge part in the effectiveness and structure of code blocks. Indentation has what is called indentation levels, and statements with the same indentation level are part of the same block of code. The level of indentation is the spacing before the lines of code in the code block. This spacing can either be done with the tab key or 4 single spaces. To better understand the importance of indentation, let's use a relatable dream that most of us would love to have in real life, and some of us do. Imagine you just bought a huge house in a fancy neighborhood, and this house has a large separate garage. In this garage, you keep 3 of your most prized sports cars that you love to drive. To keep your vehicle safe, like any other responsible owner, you lock your vehicles in the garage every night. But to get to your cars the next day, you need a key or a garage door opener. And if you don't have that key or garage door opener, you're locked out of your garage without a way to get to your babies. Well, that key or garage door opener is like the indentation level, and the cars are the lines of code in your code block. Without the proper keys or indentation level, there is an issue or an error, and you can't get to your cars or lines of code in your code block. Whether you use the tab or 4 individual spaces per indentation level, you must be consistent with which method you choose. Inconsistency of this method can lead to errors in your code that can be overlooked and difficult to debug. In most IDEs or code editors, the default indent for code blocks is 4 spaces and is automatically done when a certain code block indicating symbol is used. and that symbol is the colon. Python uses the colon symbol to show where a block of code begins in statements such as functions, loops, and many others. The code block ends when the code is unindented or further indented to a new level. The colon enhances readability of the code, which makes the code flow into the indented block much easier. In addition, it helps code editors and/or IDEs automatically indent the next line if the previous line contains a colon. Now, before we move on to the coding examples for this lecture, let's speak about common errors caused by improper formatting of code blocks in Python. As we stated earlier, using a mix of tabs as well as spaces to identify an indentation can cause errors in your code. While they both do the same thing, if used interchangeably in code, this can also confuse your code readers in reference to which method you're using. Because Python follows strict guidelines when it comes to arranging the code, if any indentation is in the wrong place, an indentation error is guaranteed. If you are using compound statements such as for, while, and if, and you placed an indentation in the wrong place, you will also receive an indentation error. And finally, it is possible to make an indentation error and Python not recognize the problem. This is called a logical error. Logical errors can be the most difficult to find and fix. They occur when the program runs without crashing, but creates an incorrect result. The error is caused by a mistake in the program's logic, which means the syntax can be correct so as to not trip an error in Python, but the code is logically wrong. So that's enough of talking about it. Let's see these Python code blocks and indentations in action. So let's talk about blocks of code in reference to the same indentation levels. Now understand that there can be unlimited lines of code in any block of code. There are also two separate types of indentation levels. You can have code blocks on the same indentation levels or code blocks on different or multiple indentation levels. That usually includes compound statements. So what we have here is just a simple print statement that prints, "Hello, A to C Python fans." This simple line of code is considered a one-line block of code with only one indentation level. In our next snippet, we have two lines of code that also have similar indentation levels. By that I mean they are both left aligned and neither is indented, and is considered a two-line block of code. In our third snippet, we now see three lines of code, all with the same indentation level. So the theme with all these code examples we've seen is that they all have similar indentation levels and are all one block of code. Now let's take these code examples one step further. What if we took those 6 lines of code that we reviewed in the previous slide and combined them together? What would we have? Well, we would have 6 lines of code that all have the same indentation level. And because of this fact, they're considered one block of code. Now let's talk about blocks of code with different indentation levels. On the screen we have a simple if statement, and as you can see, it no longer has the same indentation level. Earlier in our lecture we spoke about the colon character and how it plays an important role in the identification of multiple blocks of code. Remember, when using certain statements and clauses, the colon identifies the beginning of a code block. So the code that we have on the screen is considered a one-line block of code. Next, we see another compound statement that uses a while loop. It contains a colon at the end of the first line, which indicates the beginning of a block of code. Below we have 2 lines of code, which makes this a 2-line block of code. Note, each of these examples are considered to be one block of code. So let's discuss code blocks with multiple indentations. What we have on the screen is a snippet of code from a tax software program. In this example, we're going to break down each section of the code, and hopefully it will help you understand how the overall concept of code blocks and multiple indentation levels work in Python. So the first block of code in yellow starts with if country is equal to or is USA. As you'll notice, it starts out with a compound statement if and ends with a colon. It's then followed by an indentation of 2 lines of code. So code block 1 is a 2-line block of code. Our second code block starts with our first code block. Code block number 2 starts an if statement, if state in New York, comma, Washington, with the line ending in a colon. It's then followed by an indentation in blue and is considered a 2-line block of code. Now, as we look at the next block of code, we start to see how an unindentation can create code blocks. In code block number 3, in orange, we have an unindented by 1 level elif statement that is considered a continuation of the if statement in code block number 2. In other words, code block number 3 is a 1-line block of code that is at the same indentation level and is a continuation of code block number 2. In our fourth code block in gray, the else statements are considered a 1-line block of code that is unindented another level, matching the indentation level that is a continuation of code block number 1. And finally, we have the last code block in our program, a simple print statement. As you notice, it matches the indentation level of its predecessors, code block number 1 and 4. Now let's take a look at some of the possible errors that you can encounter when working with code blocks and indentations within Python. So let's print the example on the screen and see what errors, if any, we receive. And we get a indentation error expected an indented block. It seems that Python is expecting an indented block where there is none in line 3. When we revisit line 3 in the code, we see we have an unindented print statement. As we look at line 2, we see an if statement that ends in a colon. This indicates the start of a code block, and that's where our error lies. In line 3, the print statement is not indented, which causes our error. So we indent line 3 with a tab and rerun the code. But now we receive the same error, but in a different location. This time our error is on line 5. Looking at line 5 in the code, we seem to have another print statement that is also not indented. But when we go to line 4, we see we have an else statement ending in a colon. And we've learned from our previous error that this also indicates the start of a code block, which means there needs to be a tab at the beginning of line 5. When we correct this and rerun the code, the errors are gone and the code prints correctly. In our next example, we have a snippet of code from a course grading program. So let's run it. And we receive an error, indentation error, unindent does not match any outer indentation level. The error insinuates that we have an indented level that does not match its outer level. If we look back at the possible location of the error, it directs us to line 11. On line 11, we see an else statement that should match the indentation level of the elif statement blocks above it. But when we take a closer look, the else statement is too far left aligned and is only indented by 1 space. So we line up the else statement with the elif blocks and correct the position of our print statement and rerun the code, and the error is gone. In our next example, we have a simple 1-line block of code. When we run this code, we get an indentation error, unexpected indent. This simply means that the code has an indentation where it shouldn't be one. It directs us to line 2 where we see a print statement that looks okay, but it's indented. As we covered earlier in the lecture portion of our video, indentation of code in Python is done when there is a colon. Looking at line 1 of the code, all we see is the variable book that equals a statement. This is not a compound statement, and the end of the statement has no colon, nor does it need one. So to fix this error, we'll need to unindent the print statement on line 2 so that it's at the same indentation level of line 1, and the error should go away. We rerun the code. No more errors. In our next example, we have a variable that equals a list of student names followed by a for loop that prints out each student's name. When we run the code, we get a syntax error, invalid syntax. Now, invalid syntax errors are common in Python, so let's look at what it identifies as an issue. It seems to be expecting something at the end of the for loop in line 3. Because we have a compound statement, a for loop, we will automatically have the beginning of a block of code indented. With that known, it looks like we're missing the colon at the end of the for loop line. So we add it in and rerun the code, and our code is error-free. Our next example is a lesson in logical errors with reference to code blocks and indentation. Using the code from our earlier error example, we will see how a logical error in Python can be rather tricky to catch. When we run the code, we notice that we didn't receive any errors and the code seems to run fine. If you're not careful, you will see this and go,
"Okay, the code looks fine. Let's move on to the next issue."
But you would be very wrong. As we stated earlier in our lecture, logical errors occur when the program runs without crashing, but creates an incorrect result. The error is caused by a mistake in the program's logic, which means the syntax can be correct so as to not trip an error in Python, but the code is logically wrong. And that's exactly what we have here. In our first line, we have a variable that creates a list of numerical grades. In that list, we have 5 different numerical grades. We also have a for loop that takes each one of those grades and compares it against the conditions of the elif and else statements below to assign it to a letter grade. But if we look at the code output, we only see 4 letter grades. We also have another problem with our output. Looking at the grades, we have 100 equals grade A, that's correct. 83 equals grade B, that's correct. 89 equals grade B, that's correct. And then we have a second 89 equals you have failed the course. Now, I don't know about you, but I'd be pretty upset as a student if the guy or girl next to me got a passing score of an 89 or B, and I got the same grade and received a failing grade for the same test. We are also missing a grade from the list in the output, but as you can see, it syntactually works and will complete the code without an error, but logically it's wrong. So what's incorrect here is we don't have our indentation levels lined up correctly. If we look at the code, we have if and else statements. They should all be part of the same code block. So their indentation levels should be matching. But as we can see, it doesn't. So to fix this, we would simply line the else statement and its indented print statement up correctly and reprint the code. And now we can see that we have 5 letter grades that match the numeric equivalent of our list above. So in our final example, let's use the same grading code as we saw in our last example. By just looking at the code, the syntax looks right, and we should be able to run this code without an error. So let's run it. And we receive a TabError, inconsistent use of tabs and spaces in indentation. It references us to line 11 where our else statement resides. But as we stated before, just looking at it, we can see no problems. Everything is indented properly, the code structure looks fine. This error indicates that somewhere in this program we have a combination of both spaces and tabs to indent code. And that's a no-no in Python. As referenced earlier in our lecture quoted from the PEP8 guide, Python disallows mixing tabs and spaces for indentation. So to resolve the issue, let's click in front of the else statement and see if we're using 4 spaces or a tab to indent. It looks like we're using a tab. This is fine if everywhere else we're coding also uses a tab, but we know this is not true. So to be thorough, let's start at the beginning of the code and see which indentation we're using. So it looks like we're using 4 spaces to indent each code block. And the only place where we're using a tab is on line 11. So we change the tab to spaces on line 11. And we run the code, and we seem to be error-free. Well, that's it for this video. I hope you found value in it. And if you want more free of charge Python tips, tricks, and tutorials, hit the subscribe button so you don't miss a thing. Thanks for watching, and I'll see you in next month's class.